Alright, let's have a look at cone number 2. So we've got a top diameter of 100, a base diameter of 150, a vertical height of 125, which is that distance there. It says draw the front elevation of the plan view at the bottom. So we'll draw that, and underneath we'll draw the 2 circles. And number the pattern for clarity. So this, when we go to make it a middle, we'll add a 10mm allowance. I'm not going to do that here, I'm just going to show you how to mark it out. And we'll go through the calculations towards the end. So let's draw this, let's start drawing this. And because of the size of the paper, I'm going to do 1/2 scale again, just to make sure it fits there. So I'll just start by, I'm going to make sure I'm at least, say, 40mm up the bottom of the page or sheet, depending if we're doing it middle or not. Just draw a line across. And square a line down from that one. Now, 1/2 scale, so I'm going to be doing 50 diameter for the top and 75 diameter for the bottom. So 75 divided by 2 is 37.5. So I'm going to mark that one. And 50 divided by 2 is 25. Now I'll get my compass in this case. Obviously we'll be using dividers when we work with metal. And I'll just double check that, so we should have 75, yep, that looks good, and 50, so that's looking pretty good there. I've noticed my square line doesn't quite make it all the way down, so I'll just tidy that up. And I also need to bring it up anyway, so I'll bring this further up and try and bring it most of the way along the sheet. Right, now we'll do the front elevation. So I'm just going to draw that above this one, so anywhere is good really, as long as it's off the edge. And I'll square those lines up here as well. But first thing I'll do actually is the height was 125, so half of that is 62.5, so I'll measure that off. And I'll just bring that across the page as well. Now I'll bring those other lines up there. So there's the bottom one here. Top one here. And I'm just lightly going to fill that in like that. Now what I need to do is connect these points to find where these lines would meet. If I connect them all up, that's going to be our pivot point for marking out. So let's draw these lines in here. And I'll bring this one straight up just to make sure I've got everything central. Now what I'll do is I'll divide the bottom spigot into 12, so I'll have it on that bigger radius there, just double check it, and go from each of these 4 points. And I'll just go around and label them. So I'll start with 1, 2, 3. There's our 12 points. So you can see we've got this length here by connecting these lines up. So if I just darken this, make it a bit easier to see. So this is our slant length here, so from that point way down to that corner. So I've just went and got an extension for the compass, so what I'm going to do is grab that bottom length there, and we have a thing called a trammel in the workshop. Depending how big this is, we might be able to use dividers for it. And what I'll do is you can carry it on out that way. So yeah, that's actually what we'll do for this one. We'll carry it on out this way from that point, and this other one here. Now if I grab a line, and I can start this pattern directly onto it, but I'm going to start it a little bit off, so I'll go to that point and just come over here a wee bit, and I'll call that the side. So I'm just doing that to separate the pattern from the view. Now I can take that segment length, so the 1/12 of the bottom circumference. So I'm just going to set that up, and I'll walk it around just to make sure it's not growing or shrinking or anything. So it seems like it's growing a wee bit, so I'll just adjust that in a tad. And it was shrinking a wee bit, so let's try another go. There's a good reason why we can calculate this, and it's a lot safer. It's a lot safer bet to do that, because yeah, you imagine 0.5 mil 12 times is 6 mil, so that can be the difference between a pattern that works and one that doesn't. So we'll go around this 12 times. And I'll just make sure I label my points there. So we've got 1, 2, 3, 4. And back to 1 again over here. And I can just draw a line straight across to that point up there where they all meet. So that'll be our pattern there. Now what we can do is we can go for a bit of these calculations here. So I'm just gonna, so the one it's asking for is calculate the true length. So the true length, it's got this here, so that's distance between here and here. So if you think about it, we've got on this one we've got 50 diameter and 75 diameter. So we go 75 minus 50, and that leaves us with our two sides here. Divide by 2, 12.5 a side, so we've got 12.5, and vertically it was 62.5. This is for the 1/2 scale that I'm doing. Obviously you double it for the middle one, which would do twice as big. So now I can do a bit of Pythagoras theorem there. So c squared equals a squared plus b squared. Rearrange it a little bit. C equals the square root of a squared plus b squared. A squared and b, a and b are just either of these two sides here. C always has to be the hypotenuse. So C, which is going to be our true length, is equal to the square root of 62.5 squared plus 12.5 squared, which equals 63.74. And we can just measure that so we can check if our pattern's looking good. So yeah, it looks pretty good. It's basically 64, as close as you can see it with your eye. So we've got that true length, so I'll just call that TL. So that's the thing it's asking for, and calculate the circumference length of the bottom and top circles. So circumference equals diameter times pi. So for the top circumference, I'll just call it top C, we've got 50 times pi, and for the bottom C, we've got 75 times pi. So I'll just remind you again that this is 1/2 scale, so don't use these numbers for your full scale ones. 50 times pi, so we've got 157.1. That's the top, and 75 times pi, which is 235.6. So there's true length, top circumference, bottom circumference. Now also what I'll do is I will just check the chord length. So for that I need to figure out first the slant length here, the length to this point. So what I can do is use a ratio of triangles here. So this big triangle, say I don't know this, I can measure it, but I want to do it mathematically to make sure it's right. So I've got from there to there, I've got 37.5, and this one you see I've got 62.5 and 12.5. So all I can also do here is use this true length. So let's say we'll do that, it'll save us one step. So that true length is 63.74. So I can just make a ratio out of these two. So at 12.5 down there over 63.74, and that will be equal to 37.5 if I imagine this is a big triangle, divide by this slant length, so this whole height from this point to the bottom there. So we don't know that, so we'll call that x for now. And if I work that out and then I swap that back round, so let's do that. 12.5 so 0.1961 equals 37.5 over x. Now if I times both sides by x and then divide it by this, basically what happens is these two swap over. So x will be equal to 37.5 divided by 0.1961. I'll just put 37.5 divided by answer in the calculator to keep all those lengths. And so now we've got a slant length of 191.22. So what I can do there is just check, and I'll just draw it in here so we're clear about what we're doing. It's the slant length, the SL, and it should be, according to the calculations, 191.22. So let's have a look. So you can see, yeah, it's like half a mil too small, maybe, from what I've drawn, but you know, it's not too bad for accuracy doing it manually. So what we can do now is we can work out the chord length, which is the length between here to here. It's the chord length. So we'll do that just for pattern checking sake, so we know the pattern's right. So the formula for that, we go chord length equals 2 times slant length times sine 180 times r over slant length. So it looks kind of complicated, but it's not really once you've written the calculator. So we do 2 times 191.22 times sine 180 times r, so r is that radius there, 37.5, and over slant length again, which was 191.22, and let's put that in the calculator and see what we get. So we check our pattern. 2 times so we get a chord length of essentially 221. So that's our chord length. Now we'll use that to check the pattern. So it'll be 221, so see, roughly like a mil, maybe half a mil to a mil's too small. And that's just a accumulation of errors from drawing this out by hand. And the last bit of mess we need to do for this one is this angle. So that's asking for, it's drawn on that side on this bit. So if we look at this smaller triangle again, we've got 62.5 and 12.5. So over 12.5, 62.5. So I'm just looking at this section here. So if you remember your SOHCAHTOA, we have opposite and adjacent. So TOA, so tan equals opposite over adjacent. So let's put these numbers in. 62.5 over 12.5 and that's, to write it out a long way, that will equal, so we need to do the -1 on that answer as well, the inverse tan, because it's the tan of it, so we want the inverse. So if we go 62.5 divide by 12.5 is 5, tan to the -1 of that answer, 78.7 degrees. Let's put that in. And that's the angle. So yeah, there is a bit of maths going on this one. So yeah, pause and follow along if you want to do this maths pre-coming into the class. That would be good, but just remember to use these sizes here. So I'll flick you guys the workbook in the email, and you can work on the maths, and if you have any drawing equipment you can also draw it at home. Alright, so now I'm going to cut this out, roll it up and show you. Right, so here we have the pattern. It's a nice simple one really. Looking down on it, so you've got that circumference there, so obviously stepping it out, you see the little increments in there. You roll those round like so. That's the front view, like that, and we'll check that diameter there as well. So that looks all pretty good to me. Yep, that'll do. So there we have it.